Okay, I've got an even numbered problem up on the board for us to try now. So number 62 from your text, 1 over secant alpha minus tan alpha equals secant alpha plus tan alpha. Now in a minute I'm going to suggest that you pause the video and try to work this out on your own and then tune back in to check your work. But before I do that, I just want to say a couple of things, and I'm going to remind you of this in the next video too, because it really is important. First, there is nothing wrong with you if this is not obvious to you. It's not obvious to me that these things are true. I know that it is. Couple reasons. One, I believe the book. They said to prove this. I think they're only going to ask us to prove something that's true. Two, I did this problem yesterday, but I accidentally cut off a quarter of the screen, so I'm reshooting this video. So I proved this yesterday, so I know it's true. But it's not obvious looking at it that it's true, and there's nothing wrong with you if it's not, okay? So that's not the point of this. The point is to be able to systematically simplify things until it becomes clear that the two sides are the same. The second thing, I don't usually start a problem knowing if I'm going to just simplify one side until I get to the other, or if I'm going to do the 3-paragraph method. I'm going to simplify as long as I see things that look like good choices. And if I say, you know what, I think I've simplified this as much as I can, and I'm not where I want to be yet, then I'll switch and start working with the other side. Okay. So with those notes in mind, pause the video, try to prove this, tune back in to check your work. Welcome back. And there is more than one way to prove trig identities, so it's entirely possible that you did a proof that is correct that's not going to exactly match mine. And if that's the case, I encourage you to just show me that work in office hours or work with one of the online tutors, have them take a look at your work and just make sure that it's okay. All right, so I'm just going to label this is the left-hand side, and this is the right-hand side. And I could start with either one. I'm going to go ahead and start with the left-hand side, and I'm just going to write things in terms of sines and cosines. That's pretty much my go-to unless I see something else that sort of jumps out at me. So I'm going to say this is 1 over, secant is 1 over cosine alpha, minus tangent is sine alpha over cosine of alpha. Now, what I like about that is that I've got a common denominator now for the fractions on the bottom. They're both over cosine, so I can go ahead and just write that as 1 fraction over cosine of alpha. On top, I'm going to have 1 minus sine of alpha. Okay, but now if I'm dividing by a fraction, I know that I'm really just multiplying by the reciprocal. So I can write this as cosine of alpha over 1 minus sine of alpha. And so that's just cosine of alpha over 1 minus sine of alpha. That's my left-hand side. I've written it in terms of sines and cosines. I feel pretty good about that. I'm not where I want to be, but I think I'm going to stop. I think I'm going to switch to the 3-paragraph method. So probably should have labeled, I was starting with the left-hand side here. Okay. So now, new paragraph, right-hand side, not connected with an equal sign to the left-hand side above it. That's secant of alpha plus tangent of alpha. And again, the first thing I'm going to do is I'm going to write this in terms of sines and cosines. First of all, that's usually my go-to. Second, that's what I did with the other side. So if I'm trying to make them match, it makes sense to do the same basic thing. So this is 1 over cosine alpha plus sine alpha over cosine alpha. And so I've got that common denominator of cosine alpha, and then I've got 1 plus sine alpha on top. Now, at this point, I've simplified them both so that they're in terms of sines and cosines. It's not super obvious that these are the same, but I'm noticing that in this one I have a factor of 1 minus sine alpha, and if this one I have a factor of 1 plus sine alpha. And I know that that product would be 1 minus sine squared alpha, which would allow me to use my Pythagorean identity. So, if I just had this, I'd probably say, that's as simple as it's going to get. Since I'm trying to get to this, I'm going to try multiplying by 1 in the form of 1 minus sine alpha over 1 minus sine alpha. That's going to do a couple of things for me. Notice it puts a 1 sine minus sine alpha in the denominator, which is what I'm trying to get to. But then also when I FOIL out that top, I'm going to get 1 minus sine alpha plus sine alpha minus sine squared alpha. And of course, the outsides and the insides cancel. And if you're comfortable seeing that and going right to that, that's totally fine. Now on bottom, I've got cosine of alpha times 1 minus sine alpha. Notice I'm choosing not to distribute that multiplication because I like having this in the denominator. I don't want to muddy it up. That's sort of what my goal is, to have just that in the denominator. So now I can say, all right, we've got 1 minus sine squared alpha over cosine alpha times 1 minus sine alpha. But by my Pythagorean identity, I know that that's cosine squared alpha over cosine alpha times 1 minus sine alpha. And now I can cancel one factor of cosine. And that's going to leave me with cosine of alpha over 1 minus sine of alpha. And that's what I had simplified the left-hand side to. So I was able to simplify them to the same thing. My third paragraph is just to point out left-hand side is equal to the right-hand side because I got them to look exactly the same. Notice on that one, it didn't just sort of fall out naturally that I just simplified it and that was where I was. I had to sort of look at what my goal was that I was trying to make it match, and that motivated my decision to multiply by 1 in this form.